To this point, we have gone through three types of reactions that occur with organic molecules: combustion, substitution, and addition. Combustion of hydrocarbons, or of C, H, and O compounds, produces carbon dioxide and water. Substitution reactions remove an H and replace it with something else. Addition reactions break one of the bonds in a multiple bond and insert two things, one to each of the two atoms that formerly had the multiple bond. The subject of this lesson is the condensation reaction, also called an elimination or dehydration reaction, and these are aptly named because water is a product. What happens in a condensation reaction is that one reactant provides an H and the other provides an OH. They form the water. And what's left then bonds together in, you might think of a synthesis type of reaction. Let's take a couple of examples. Here we've got benzene reacting with HNO3. Since there is no oxygen in benzene, clearly benzene is going to provide the H, and the HNO3 will provide the OH. We're going to produce water, and then what's left bonds together. What we have is the benzene ring with a spot open because an H has been removed, and when we take an OH away from HNO3, we're left with NO2, and that's what you get. Nitrobenzene is what we'd call that molecule. Let's try this reaction down here at the bottom. One of these will provide an H, the other will provide an OH. It doesn't necessarily matter which provides which, but we're definitely going to get water, and then you can see that what's left is going to bond together to look something like that. You might recognize this molecule in the lower left as an alcohol, and the one next to it is also an alcohol. And when two alcohols react together in a condensation reaction, you obviously get water, and you also get an ether. Condensation reactions polymerize amino acids into proteins. Here's one generic amino acid. Here's another generic amino acid. You can see that an amino acid has in it a carboxyl group. That's from the carboxylic acid. You can see those on the right side of these molecules. And then they also have an amino group right there. So that's why they're called amino acids, because they've got this amine group in there, and they've also got the COOH group in there. Note that amino acids have amine groups attached to the carbon that's next to that carboxyl group. And so what you can see here is that we're going to take the OH from the carboxyl group, and we're going to take an H from the other molecule's amino group, and we're going to form water, and then what's left is going to join together. That would be a bit of a protein, and we could continue doing this at one amino acid on each end until we get this huge chain of amino acids, and long chains of amino acids we call proteins. Amides can be formed in condensation reactions between carboxylic acids and amines. Let's write the equation for the reaction between butanoic acid and ammonia. Butanoic acid is a carboxylic acid that has 4 carbons. There's our structure of butanoic acid. Ammonia, of course, is NH3. You're supposed to know that. If you don't, learn it. And in a condensation reaction, something provides an OH and something provides an H. I wonder who's going to offer up whom. Since ammonia doesn't have any OH, I think ammonia is going to offer the H, and the butanoic acid is going to offer up the OH. Then what's left joins. So what's left is this 4-carbon chain with the double bonded oxygen, and then the amino group right there, which shows you that whenever you react a carboxylic acid with an amine, you get an amide. You might remember that this structure here with the double bond carbon oxygen and then a nitrogen next to that carbon, that's an amide. Let's summarize. In a condensation reaction, two molecules join together to form a more massive molecule. One molecule releases an H, freeing up a bonding spot on that molecule, and the other releases an OH, freeing up a bonding spot on that molecule. The two molecules become one by connecting at their bonding spots, and the discarded H and OH come together to form water. Condensation reactions are also called elimination or dehydration reactions.